Okay, we're starting a new unit, and our first section of information is on solving and graphing compound inequalities. This is something that you have talked about previously. An inequality is anything with an inequality symbol, like a less than, greater than, less than or equal to, greater than or equal to, or a not equal to symbol. A compound inequality is an inequality with more than one condition, or in other words, more than one inequality symbol. We have two types of compound inequalities. We have what we call and inequalities and or inequalities, also known as conjunction and disjunction inequalities. So this would be an example of an and conjunction. So anytime you have an inequality or a compound inequality that's kind of smushed together as one, where this middle term is shared by both the first term and the last term, this is always an and inequality, and it can be rewritten as such. So we take the 2x is less than 3x minus 1, and 3x minus 1 is also less than 5. So we can split it up just like that. And when we solve this, we solve it the same way we solve an equation. So you would subtract 3x's from both sides and then divide by the number in front of the x. We would add 1 to both sides and then divide by the number in front of the x. And we get two answers. Okay, so we get x is greater than 1. So if you remember, we put an open circle at 1 because the solution is not equal to 1. And then anything greater than that is to the right. And we get x is less than, sorry, hold on. I'm just trying to make this show up. No. Okay. Okay, and when we solve this side of the inequality, we get x is less than 2. An inequality means that the answer has to fulfill both this and this. So our solution is only going to be where both of our arrows overlap. Okay. So if we were to graph this on a coordinate plane, this is what we would have. Okay, so again, it's where our two shadings overlap. Okay, and then I finally just wanted to show you the last type of compound inequality. That's an and or a conjunction, and that's just where we have essentially two separate inequalities, but they are looked at as all part of the same problem because the answer for whatever x is has to fulfill both this side and this side at the same time. Okay. An or inequality is separated with the word or, and this one is less restrictive. It means that the answer for x, whatever x is, can fulfill what is here or what's here. So as long as it works for one or the other, it's a solution. Whereas here again, it had to work here and here at the same time. Okay, so when we solve this, again, we get x is less than 1, and we get x is, sorry, greater than 4. And we don't have to worry about overlap. Our answer is going to be anywhere where we have a solution at all. Okay, and again, if we were to graph this on a coordinate plane, okay, again, we have x is less than 1 and x is greater than 4. And again, any solution that's within our shaded region would work. Whereas again, with an and solution, we're looking for only a solution that fulfills both the purple and the green at the same time. And that's all she wrote. If you have any questions, come in next class with them and I'll see you then.